So we have several different systems, of course. I'll be mentioning 4 different ones that have some recent updates in them: the VersaProbe 3, the PHI 710 Auger, the Quantas system, and the TOF-2. So for the VersaProbe 3, we have some exciting news for those of you that are interested in electronic band characterization of materials. We have UPS, LIPes, and reels for that, and I'll describe that a little bit more in the coming slide. We do have a cluster size measurement tool for looking at cluster sizes on the GCIB, and some new software tools as well. So for decades now, we've had UPS here at PHI, and that's excellent for looking at the valence band of materials, but that kind of only gives you half the picture. We now have available LIPes, or low energy inverse photoelectron spectroscopy. They can give you information on the conduction band, and so you can now determine the electron affinity of your materials. And putting the 2 techniques together, you can very nicely determine the band gap of materials and look at the whole electronic structure of materials. We also have reels available recently here, and that's also used for looking at band gaps, especially wide band gap materials, also for looking at detecting hydrogen as well as chemical structure from core levels such as carbon. I mentioned earlier that we have an Argon cluster size measurement tool here in the lab. That's very important for looking at the actual cluster size, and just as important as the distribution of the clusters from a given setting on the system. And so it's especially important to make sure you're not getting very low size clusters, and especially monatomic argon coming out of your gun. In terms of software tools, we have a few new exciting things. Stratify is our new thin film structure analysis software that very nicely, using angle-dependent measurements or even a single measurement for some materials, you can calculate the thickness of thin film structures. And you can see here in the diagram, you can obtain relative depth plots to tell you in a relative sense where different layers are located, and then that will generate a depth profile looking plot for your thin films. We also have an improved user interface. We have a dashboard, or what we call a dashboard, that shows up on the left side of your screen, and this combines a series of different menus to keep things more organized and to allow you to very easily get to different menus very quickly. And we also have a greatly improved queue to allow for setting up automated analyses. And you can even modify this queue once it's started now. So some great improvements there. On the still on the XPS side, we have our newest XPS, the Quantas, which is a combined XPS soft X-ray along with a hard X-ray using chromium X-rays. This has a dual Argon GCIB ion gun in the same column. And we're also working on empirical RSFs for the chromium hard X-ray source. And Ben Schmidt will be having a Quantas talk tomorrow, and so he'll go into much more detail on the instrument. On the Auger side, kind of similar to what we've done on the VersaProbe, where customers want more and more different techniques added to be able to do correlative measurements. We're doing the same thing on the 710. So we can now add EDS for quick bulk analysis. We can do backscattered imaging or Z contrast. We can do EBSD for crystalline grain orientation and strain measurements. We can put a fib for in situ cross-sectioning. We have an in situ fracturing mount that's in there for looking at metallurgical fractures. And we can also put a 4-contact stage and mount in the system. So Ashley Maloney will be giving a talk later today that'll be describing this system in more detail. And finally, the TOF-2, we have MSMS for unambiguous peak identification, and Greg Fisher will be giving a talk tomorrow on looking at how this works as well as some applications. We also have some new data reduction software on the TOF, and data reduction package, TOF-DR, and this is referred to as review. And this enables instant viewing of the raw TOF-SIMS data, and so that you can look at the peaks as well as instantaneously look at the images from those peaks and the profile data. And so it's especially important when you're looking for, say, a contaminant in an interface, an unknown contaminant. You can scroll through the different peaks and look at their depth distribution as well as their image.